Good evening, everyone. Welcome to the Aquarium of the Pacific. I'm Jerry Schubel, president of the Aquarium, and although I can't see any of you this evening, I'm assuming you're all out there ready to listen to this very important lecture. I want to thank our regular lecture sponsors, Gazette Newspapers and the Courtyard Marriott, and tonight we have a very special sponsor, the San Gabriel and Lower Los Angeles Rivers and Mountains Conservancy, the RMC. This is one of 10 conservancies in the state of California, but it's the only one that focuses on an urban area, and its programs will be very important to the future of this region. We've been partners with them now for a number of years. They've been supporters of our exhibits and in our expansion of Pacific Visions, and we are very grateful to them. Tonight, historian and author Sunil Amrith is going to give a talk about his latest book, or maybe it's not his latest, Unruly Waters, How Rains, Rivers, Coasts, and Seas Have Shaped Asia's History. He is the Mehra family professor of South Asian Studies at Harvard University. He also serves as the interim director of the Mahindra Humanities Center, and he's a director of the Joint Center for History and Economics. He's a MacArthur Fellow, and in 2016, he received the Infosys Prize in Humanities. In addition to Unruly Waters, he has written Crossing the Bay of Bengal, The Furies of Nature and the Fortunes of Migrants, and that was awarded the American Historical Association's Richards Prize in South Asian History. He also wrote Migration and Diaspora in Modern Asia and Decolonizing International Health in South and Southeast Asia. He serves on a number of editorial boards. He received his undergraduate and graduate degrees from the University of Cambridge, and before coming to Harvard in 2015, he spent 9 years at the University of London, and this summer he moves south from Harvard to Yale University. It's a real pleasure to welcome Professor Sunil Amrith. Sunil.
Thank you so much, Jerry, for your kind introduction and for the invitation. Thank you all for joining us for this virtual lecture. I hope you're all safe and well, wherever you're watching from. I must say that of all the I was due to give this spring, this is the one I was most looking forward to. I'm glad to be able to do it remotely and hope to visit the aquarium on another occasion. Though we can't be together for a discussion afterwards, I'm always happy to hear from anyone who has questions or comments. My email address is on this first slide, so please feel free to reach out. Given the aquarium's dedication to studying the peoples, cultures, and marine life of the Pacific, what I'd like to do this evening is to share some of my work on its maritime neighbor, the Indian Ocean. The Indian and Pacific oceanic worlds are deeply connected. Some even now speak of the Indo-Pacific. They're connected ecologically, economically, politically, and I hope that a few of those connections will emerge in my talk. The work I'm going to share with you is drawn from two of my books, which I think of as interconnected. They tell different facets of the same large story. Crossing the Bay of Bengal came out a few years ago in 2013, and Unruly Waters came out last year. And the large story that they both engage with is the story of the Indian Ocean, an intensively networked space of both human and environmental history. In this evening's lecture, I'd like to take us through three broad moments in the life of the Indian Ocean. The first is its deep history of commerce and cultural exchange that long predated the arrival of Europeans, but which was reoriented by European domination after the 18th century. In the 19th century, the Indian Ocean reached its zenith of integration. It was a violent, painful integration that forced people together. It also unleashed an unruly and sometimes insurgent process of cultural mixture that still characterizes Indian Ocean societies today. The second historical moment is the mid-20th century moment, when the liberatory possibilities with the end of empire and decolonization were tempered by a sense of enclosure. As new borders divided insiders, outsiders, majority from minorities. Finally, in a third ongoing moment, we confront a present and future of foreboding, as the rising waters of the Indian Ocean menace those who inhabit its coastal arc. The specter of climate change hangs over the Indian Ocean, the same moment that it has re-emerged as a region of strategic competition, not least between India and China, because it is the world's major conduit, feeding our collective action to petroleum. So let me begin with a long history, a deeper history of the Indian Ocean. The Indian Ocean was never a canvas for European merchant companies to reshape in their own image. Long before the arrival of Europeans, the regularly reversing monsoon winds allowed trade from across the ocean's rim to move, settle, and trade with one another. This is a photo from the Budong Valley in Malaysia, Western Malaysia, in the state of Kedah. Not far from the port city of Penang, it's one of the largest and most important archaeological sites in Malaysia, and it testifies to the presence in the first millennium, thriving community of Tamil-speaking traders from South India. Chinese ships visited every port on the Indian Ocean's rim. Merchants from Gujarat and West India moved money and traded in cloth and cloves along the East African coast. In fact, it was the economic vitality of this world that attracted Europeans in the first place. This is a sample of Coromandel cloth from the southeastern coast of India, just to remind us that Indian textiles were in some ways the staple currency of the commercial world that spanned the Indian Ocean. The Portuguese entry into the ocean was made possible by lethal cannons made of sturdier metal. The Portuguese sailed on ships furnished with more effective navigational aids. Though it was brutal, Portuguese power was concentrated at strategic coastal fortresses. It was fragile, it never reached very far inland. Violence was not unknown in the Indian Ocean before the arrival of Europeans. What was truly new were the claims of exclusive sovereignty over the sea that European chartered companies, backed by states and navies, asserted over land and sea. As the Dutch and English East India companies would challenge Portuguese supremacy in the 17th century, the maritime highway between India and China became a corridor of conflict. European settlements in the Indian Ocean, known as factories, almost exclusively coastal. And in thinking of the coast as space of encounter and incursion, I'd read a few lines from the poet Ranjit Hoskote from his wonderful recent collection, Jonah Whale. This is a verse from a poem called As It Emptieth Itself. The river stabs the sea. Water, salt and fresh, bursts up through the splintered rib of the scuttled boat that's trail wake of belly-up fish. Thalassa. The compass bird points to the coast, to a river mouth, disgorging crumbled islands, to the tide wash that number the wounds by which conquerors named it. Trapped by the trader's sovereign eye, by the surveyors of revenue lands, the purveyors of cloves and camphor, the coast signals its own tongue, breaking with the horizon's grammar a stutter. And I love the way this poem evokes both the ecological liminality of the coasts, the point where the great rivers meet the sea, and its political centrality to the new ambitions of traders who come from far away. For every claimant to power and wealth in the Indian Ocean, well in the age of steam power, the knowledge of climate was vital. The word monsoon appeared in the English language first in the late 16th century, derived from the Portuguese monção. It comes from Arabic mausim, for season. In its simplest definition, the monsoon is a weather system of regularly reversing winds, characterized by pronounced wet and dry seasons. The monsoon allowed the Indian Ocean to be traversed from the earliest times. To begin with, European navigators relied on local nautical knowledge. Among the first to inscribe this wisdom was the Arab navigator Ahmad ibn Majid in the late 15th century. For Ibn Majid, the monsoon, mausim, was above all a specific date, a date for sailing from a specific port. It's almost as we would imagine a timetable. His treatise shows how regular and predictable were the sailing schedules for each of the ocean's seas. In his discussion of the westward East Asia back to India, for example, he cautions mariners to take advantage of the favorable winds of the northeast monsoon, advising them not to set out too late in the season, while reminding them the northeast monsoon did not usually arrive in Sumatra before the beginning of January. The timing had to be just right. Ibn Majid's work was a faithful companion to sailors for hundreds of years. But as ambitions in the region grew, Europeans were no longer satisfied with the state of their navigational knowledge, their knowledge of the sea and currents and winds. By the 17th century, English and Dutch navigational charts surpassed those of the Portuguese. The captains of East Indiamen followed established, marked routes on their voyages to the Indian Ocean. The introduction of seagoing chronometers improved the accuracy with which sailors could measure time. By the middle of the 19th century, English sailors began to collect systematic observations of the fearsome storms of the Indian Ocean that were of interest to meteorologists and sailors alike. Understanding the Indian Ocean storms owed much to the work of one retired ship's captain who was also president of the Marine Courts of Calcutta, a man named Henry Piddington. Piddington's interest in the characteristic storms of the Indian Ocean was first and foremost practical. He dedicated his work to mariners of all classes in all parts of the world. In his catalogue of different types of storms, Piddington proposed a new word, cyclone, to describe those storms driven by what he called circular or highly curved winds that characteristic the Indian Ocean at certain times during the year. He derived the cyclone from the Greek kokloma, coil of a snake. The new science of cyclones demanded attention. Sailors, Piddington insisted, for it is a question of life and death, of safety or ruin. He described a storm wave as a mass of water driven steadily along with the storm before it. Piddington published in his journal, in the Asiatic Society's journal, a series of ship's logs from which he derived his understanding, cyclones. And I'm just going to give you a snapshot of what these logs looked like. These minute observations by sailors, which really furnished the beginnings of meteorological data in the Indian Ocean world. In 1864, a cyclone struck Bengal so devastating that it spurred the development of a permanent meteorological department in India for the first time. This is from the Illustrated London News, a picture of the devastation of Calcutta, the capital of British administration in India after that 1864 cyclone. The science of meteorology presented a new way of imagining the Indian Ocean across imperial borders in an age of fervent imperial competition. The expansion of telegraphic communication allowed for a new sense of cycle emerge, a new way of envisaging weather in time and space. From the collaboration of meteorologists across imperial borders emerged an oceanic idea of Asia, linked by storm tracks that traversed sea and land, a coastal rim from the Philippines east to India in the west that shared risks to an extent previously unimagined. This illustration is from the Philippine Manila-based meteorologist, Father Jose Algué, Spanish Jesuit meteorologist, who had reconstructed the path of two particularly remarkable cyclones, beginning in the seas off the Philippines and ending up in the Bay of Bengal. So you see a sense of meteorological detective work in this map, piecing together stray isolated accounts to provide, for the first time really, the narrative of how a storm moved from the Pacific to the Indian Ocean. The network of storm warnings along the coastal crescent from India to China was like a mirror of Asia's maritime geography. The names of the stations that broadcast telegraph reports were the names of the great ports. The tracks of the cyclones that they monitored were the tracks of the busiest shipping lanes. But as the British colonial government intensified its interventions into rural India, above all to extract land tax and recruit soldiers, research on the longer-term regularities of India's climate and rainfall, as opposed to episodic storms, pointed in a different direction. India's climatology, as opposed to its meteorology, emphasized the distinctiveness, even isolation, of the Indian subcontinent. And that phrase, the Indian subcontinent, came into vogue only in the beginning of the 20th century. Henry Bland, the first director of the Indian Meteorological Department, observed that the monsoon system rendered India a secluded and independent area of atmospheric action. The reason for that, he thought, was the gigantic barrier of the Himalayas, which in a sense enclosed India like an amphitheater, which was the metaphor that he used more than once. Sail gave way to steam towards the end of the 19th century. As the demands of industrial capitalism grew more forceful, the intimate relationship between seafaring and meteorology began to fray. In the 19th century, the transformation of the lands around the Indian Ocean accelerated. Even before that, the scale of human impact on the forests of the Indian Ocean's rim had attracted the attention of European botanists, naturalists. It's a wonderful book by historian Richard Grove back in 1995 called Green Imperialism that covers here, which points how much the islands of the ocean stimulated botanical investigation. This is in the 18th century. Grove argued that concern with these island Edens, as they were called, places like Mauritius, stimulated the very early stirrings of conservation across the Indian Ocean world. But in the 19th century, the scale of that human impact on the environments of the Indian Ocean reached new levels. The demands of British factories, the era of the Industrial Revolution, precipitated a rush on the commodities of the Indian Ocean's frontiers. A rush for sugar and tea, rubber and tin, timber, cotton. And it is in this 19th century moment that you see a very close relationship between the human history and the environmental history of the Indian Ocean. Because in order to enable this new level of exploitation of forests, land, the establishment of new plantations, human migration on a massive scale was necessary. In the 1830s, as political pressure mounted in Britain for the abolition of slavery in the British Empire, sugar planters looked instead to India, to China, for unfree labor. The demands of sugar underpinned the 19th century's worldwide shift from enslaved African labor to indentured Asian labor. And in many places, there was a direct replacement of slave labor with indentured labor. In all, around 1.5 million indentured workers moved from India alone to destinations across the Indian Atlantic worlds, to Mauritius and Natal and Fiji, also to Trinidad. Alongside indentured laborers, tens of thousands of convicted prisoners from India were transported from India across the Eastern Indian Ocean. They built roads, cleared forests, erected buildings, cultivated gardens, cleaned cities. It was the empire's violent appetite for labor, I think, that distinguished this mobility from the earlier movements of people across the Indian. And the scars of that violence, I think, still run deep in the Indian Ocean world today. The forces now choke the life from the Indian Ocean began as the unintended, initially unseen consequences of the political transitions that took place in the middle of the 20th century, as a new world arose from the ruins of war and the remnants of empires. The policies that began to reshape the chemistry of the Indian Ocean began as schemes of food security, schemes of industrialization to provide employment, schemes that actually initially represented an advance in human freedom around the Indian Ocean world, including freedom from poverty. From the mid-20th century, the Indian Ocean's political economic fragmentation as new nation states were formed had important ecological consequences. As human migration began to decline, as internal migration began to outstrip overseas migration, as individual countries began to control their borders, as India, to take one example, insisted that the country needed its own labor rather than wanting to export it overseas, as avenues of emigration closed off, as interregional trade, including the trade in rice, declined as countries sought self-sufficiency in the 1940s and 50s. Those shifts could only be sustained by a massive intensification of domestic agriculture. As they took away from oceanic trade, coastal cities grew rapidly. They turned inland, they became industrial centers. The treatment of the ocean as an extension of national territory, as fundamentally fishing ground to be exploited, had consequences that only began to become evident in the 1970s and 1980s. In a world newly divided between superpowers, in which newly independent countries asserted their rights to develop their own resources, the Indian Ocean became both a source and a conduit for that most vital of modern substances. During the Second World War, the Bengali astrophysicist Meghnad Saha saw already how important oil would be for the future. He urged soon-to-be independent countries like India not to cede their oil resources to the ever more powerful conglomerates. By the 1960s, Auguste Toussaint, the chief archivist of Mauritius and a noted local historian, wrote the first major history of the Indian Ocean. He wrote it in French in 1961, it was translated to English in 1966. And he saw, like Saha, the age of petroleum as inaugurating a new phase in the Indian Ocean's history. After the steamship and electricity came oil, Toussaint wrote back in 1961. The three formed a triad which has dominated all oceanic history until today. Toussaint compared these technologies to those deities with several arms which are found in Hindu temples. Among them, oil might appear as a kind of terrifying Shiva, frenetically danced circle of fire, principle at once of creation and destruction, yet more often engaged in destroying than creating. That was a quotation from Auguste Toussaint, archivist of Mauritius in 1961, author of the first general history of the Indian Ocean. It's certainly striking to me how prescient he seemed to be with the ending of that book. By the 1960s, the Indian Ocean was largely invisible to states in South Asia, which tended to look no further than to the waters immediately off their coasts. Migrants had once crossed the sea with few restrictions and a pattern of circular migration. Now they faced an obstacle-strewn space governed by passports and visa restrictions. Trading connections by the 1960s had reached their lowest ebb probably in centuries. Trade patterns were were reoriented along the lines of Cold War alliance, rather than the oceanic world that had linked the Indian Ocean together as an economic space. But despite its long centrality to the ambitions of empire builders, to many scientists in the 1960s that the Indian Ocean emerged as a space of investigation. So this is the paradox, that at the moment in the 1960s that the Indian Ocean, in a sense, disappears from public consciousness as a political and an economic region, that is the moment that it begins to stimulate large-scale oceanographic meteorological investigation. Paul Chernier, who worked in the Physical Oceanographic Laboratory of the National Museum of Natural History in Paris, described it in the 50s as the forlorn ocean, unknown ocean. Turning from a voyage through the Indian Ocean on his way back from the Antarctic, Chernier suggested that it was high time that an international expedition investigated the Indian Ocean. He tried to incorporate this into the 1957-58 International Geophysical Year of the UN, which of course was pivotal to the collection of all sorts of climate data that we continue to rely on. But it was too late to include the Indian Ocean in that particular expedition. And so bringing together oceanographers from Scripps, from Woods Hole, collaborators from more than 12 countries, the International Indian Ocean Expedition took place from 1959 to 1965, involving in the end 40 ships from 13 countries. It's the first major oceanographic investigation of the Indian Ocean. Oceanographers, it strikes me, were drawn to the Indian Ocean for the same reasons that medieval and early modern traders could cross it, because of the seasonal reversal of the monsoon winds. This pattern of reversal winds made the Indian Ocean unique and ripe for oceanographic investigation. Many scientists who lived on the ocean's rim, especially those in government service, had more immediate interests. The ocean's fisheries held the potential to address concerns about food shortages in Asia and Africa. Its mineral wealth had barely begun to be exploited. Unlocking the mechanism of the ocean's influence on climate could provide the key to food security and economic development. So the Indian Ocean Expedition brought together these very long-range considerations, the considerations of basic science, of oceanography, with much more immediate economic concerns. The expedition encompassed the study of currents and littoral drift, an investigation of ocean chemistry, salinity, temperature, the exploration of marine life, and especially fisheries, study of wind and atmospheric conditions, and rainfall. And it was a rare collaboration across ideological lines in the Cold War. It brought together the US, the Soviet Union. It marked the resurgence of both German and Japanese oceanography, but it also invited the participation of neighboring and often hostile states like India and Pakistan. And the idea was that the ocean had something of vital interest to all of them that transcended politics. Much of the excitement about the Indian Ocean Expedition in the 1960s came from the new technology that allowed scientists to see the sea in new ways. Sonar technology allowed them to map the Indian Ocean seafloor with accuracy. Their images evoked an underwater continent as varied in its topography as the land above. Advances in satellite technology provided synoptic pictures of cloud cover and precipitation. Among all of the Indian Ocean Expedition endeavors, one observer wrote, none contrast between past and present than meteorology. And for many scientists, the most urgent priority for the Indian Ocean expedition was to provide a better picture of Asia's climate, particularly of the Asian monsoon. The need to understand the monsoon, some of the investigators wrote, has become ever greater and more urgent in view of the scale development plans of many of the countries in the fields of agriculture, exploitation of water resources, flood control programs for ameliorating the consequences of weather extremes. The Indian Ocean expedition focused on understanding the exchange of energy between ocean and atmosphere, driven by the monsoon winds. Piece by piece, investigators sought to understand the large-scale monsoon circulation of the Indian Ocean world, connections between the Indian Ocean and the Pacific. At this time, more ominous signs emerged from the Indian Ocean expedition. 2 years before the expedition began, one of it, the scriptographer Roger Revelle, had been with his colleague, the geochemist Hans Suess, that human beings were conducting, unwittingly, a large-scale geophysical experiment with the world's climate. Within 2 centuries, Revelle and Suess wrote, "We are returning to the atmosphere and the oceans the concentrated organic carbon stored in sedimentary rocks over hundreds of millions of years." Revelle and colleagues had long-range goals for the study of the Indian Ocean. They wanted to see how far the Indian Ocean was, in their words, a dump for the waste products of industrial civilization. We've forgotten how important the Indian Ocean was to documenting anthropogenic climate change, prompting the early bearings of alarm. Data to come out of the Indian Ocean voyages suggested that the sea and the atmosphere were being affected by human activity on land. But these long-range problems, as they were called, were different from the level of human experience. The time horizons of organic research were incommensurable with those of planning for food security. Because the long-range monsoon forecast remained elusive, because understandings of climate grew ever more complex, it was easier to focus on what could be contained and controlled, one river valley at a time, as an Indian economic planner put it. Already the warmest among the world oceans, there has been a steady and continuous warming of the warm pool in the central eastern Indian Ocean over the past half century. These changes were only beginning at the time of the Indian Ocean experiment in 1960. The international cooperation of that era laid the foundations, infrastructure of data collection and ethnographic study that has made clear the Indian Ocean's plight. Recent studies have suggested a sharper warming trend in the normally cooler Western Indian Ocean, which has implications for the thermal contrasts that drive monsoon circulation. From the time of Sir Gilbert Walker in the early 20th century, it has been recognized that the Indian Ocean affects climate dynamics across the tropics. It is incredibly clear that a warming Indian Ocean has planetary effects. The 5th assessment report of the Intergovernmental Panel on Climate Change estimates that 90% of the heat generated by global warming has been accumulated in the oceans. One of the mechanisms of Indian Ocean warming has been the unexpectedly large heat transfer from the Pacific, long thought to play the most significant role in the absorption of atmospheric heat via the thoroughfare of the Indonesian seas. The same seas crossed by merchants and traders centuries, hinge of the Indo-Pacific world. The transformation of the Indian Ocean over the past few decades is not a story of warming alone. In the mid-1990s, the crew of a small research vessel noticed as they crossed the intertropical convergence zone or equator, a sharp increase in atmospheric pollutants over the northern compared with the southern Indian Ocean. A study followed, revealed the now infamous atmospheric brown cloud covering most of the Bay of Bengal, the Arabian Sea. These findings prompted oceanographers and atmospheric chemists to initiate the ocean experiment directed by the Scripps oceanographer V. Ramanathan, who was the successor to the Indian Ocean expedition of the 1960s. The experiment ran from January to March 1999. It involved more than 200 scientists from India, Europe, and the US. The haze the experiment showed was composed of sulfates, nitrates, organics, black carbon, dust, and fly ash particles, as well as natural aerosols, sea and mineral dust. 3/4 of the composition of the brown cloud were anthropogenic. The study found that the aerosol plume reaches its maximal extent and strength in the dry months of February and March, when it hovers over most of the Indian subcontinent, the Bay of Bengal, and the Arabian Sea, extending south of the equator. It is commonplace of oceanic history that the sea has shaped coastal life. The path of the monsoon winds, trade routes, storm surges and cyclones sweeping in from the sea have posed a recurrent and perennial threat to life on land. Environmental concern from the 1960s focused on the polluting effects of industry on the beach and on the coastal waters. But this experiment suggested that for the first time, something new was happening. Human activity far inland was now impacting the atmospheric chemistry of the Indian Ocean. By affecting the thermal contrast between the northern and southern Indian Ocean, the cloud was affecting the circulation that drives the monsoons. An overwhelming proportion of the pollutants that spill into the Indian Ocean every year flow out with the great rivers that empty into it. The Ganges, the Brahmaputra, the Meghna, the Godavari, the Kaveri, Krishna, the Indus. They trickle as refuse from large coastal cities that ring the ocean's rim, places that were points of departure for millions of journeys in the age of sail and steam. Because of the size and number of rivers that feed into it, the density of population around its rim, the Bay of Bengal is perhaps the most polluted of all the Indian Ocean's seas. Floods and storm surges dislodge pollutants and carry them over long distances. A plague of plastic floats out to sea. The rivers themselves are in dire health, originating as so many of them do on the Tibetan Plateau. Around 80% of the world's population lives in areas where human water security, biodiversity of river systems is under cumulative threat. And a significant live in South Asia and around the ocean rim. The excess of nutrient that flows through the rivers, most damaging is a nitrogen from agricultural fertilizer runoff, as well as from vehicle and factory exhausts, creates dead zones starved of oxygen. Writing from the southeast edge of the Bay of Bengal in the early 19th century, the British naturalist John Morford declared that no part of the world abounds in more fine fish. 2 centuries later, the fish are disappearing. The map of cities most at risk from rising water resembles a series of beads on a necklace threaded along the coastline of Asia, from the Indian to the Pacific Ocean. One study predicts that by 2070, out of the 10 cities with the most people at risk from extreme weather will be in Asia. Miami is the only non-Asian inclusion. The list includes Kolkata and Mumbai in India, Dhaka in Bangladesh, Guangzhou and Shanghai in China, Ho Chi Minh City and Haiphong in Vietnam, Bangkok in Thailand, and Yangon in Myanmar. Each one of these cities will confront any change in the interaction of land, water, winds and rains over Asia's ocean and coasts. In coastal cities along the ocean's rim, climate change compounds an existing cavalcade of risks that are severe in and of themselves. Hasty development driven by property speculation, new forms of consumption, crumbling sanitary infrastructures, and a lack of preparedness and precaution. And all of these are symptoms of profound social and economic inequalities, both among and within nations. The scale of the crisis ahead seems so forbidding that it can be unfathomable. I'll end my talk then partial and a local view. I'd like to read from the final pages of Unruly Waters. Along the coast of southeastern India are many signs of irreversible change. In a small village near Pondicherry, earlier this decade, I met Mr. Ratnam, a fisherman in his 50s, whose family had been fishers in the area for generations. On the narrow strip of beach on which we sat were granite sea walls. If not for these walls, he said, the sea would have taken the settlement long ago. The beach has been eaten away over the past 20 years, most noticeably by the construction of a large new port in Pondicherry, a few minutes along the coast. The Pondicherry Port marked the beginning of an explosion in port construction in India, with dozens of ports currently planned for India's eastern and western seaboards. They eye the newly flourishing commercial opportunity in the ocean's littoral, which is after falling into decline for the second half of the 20th century. The ports cause enormous upheaval to the coastline. Where those boats are now, Mr. Ratnam said, pointing the beach, those were all houses. Look, he said, you can see the remains of the floors of those houses. And there I saw little fragments jutting out from the soil, a small archive of coastal environmental history. He's convinced that the sea is changing in ways beyond what is visible to the eye, beyond the visibly changing extent of beach. The weather is unpredictable, he said. The seasons seem to mean nothing now. He was convinced that the monsoons are shifting. I don't understand the sea more, he said suddenly, the sea that he has known instinctively. I asked him what the future holds. Nothing, he said. There will be no fish left to catch. People experience change in space as well as in time. They mark change in terms of their memories of the seasons as they used to be, or of equal storms that now seem portents of the future. But they also mark it through traces on the landscape, through memories of old houses and old houses. Traces of those earlier times lie embedded as debris at the water's edge. Thank you very much for listening.
I think this is a very powerful story. And it's interesting, this part of the world is making the largest contribution to climate change, and it's going to suffer some serious consequences. Something like 60% or so of all the greenhouse gas emissions come from Asia. And it isn't just greenhouse gas emissions. Also, so many hundreds of millions of people use cooking stoves that are where they use wood, and the soot from the wood is depositing on top of ice and then causing that ice to melt more rapidly. I love the title, Unruly, Disruptive, Disorderly, and Not Amenable to Control. I think you've done a great job. I want to ask you a little bit, though, about the future and what's happening on the Tibetan Plateau. Because here's a case where more than 1 billion people, something like almost 20% of the population of the world, depends on meltwater from the Tibetan Plateau. And the IPCC it forecasts that between 1/3 and 1/2 of the Tibetan Plateau glaciers will be gone by the end of this century. And it will lead to water insecurity, food insecurity, because there won't be the water for farming. And it's going to have a huge impact on the future of this region. And I think the other part of it is there are no multinational agreements among the various countries in this area for sharing water. And when things get tough, people look out for their own interests. Say a word about your concern about what's happening, please, with the Tibetan Plateau and the melting of the glaciers.
My concern there is profound, and I think it's a multifaceted problem. Even before the acceleration of meltwater, you have right now, as we speak, a competition to dam the upper reach these rivers. And that itself is causing transboundary conflict and water shortage. And there are several hundred dams planned for the upper reaches of the Himalayas, not just by India and China, but also by Nepal, even Bhutan. Many of these are for hydroelectric power plants, but what is happening there is a seismically active zone. There are profound risks that come from the safety of the dams themselves. There are risks that come from the conflict over water use that will arise from the attempt by countries, in a sense, to compete with each other to dam the rivers. And many environmentalists believe that changing river flow that will arise from climate change haven't been sufficiently taken into account even in the engineering of the dams. And so I think even before we get to that catastrophic late century projection of what's going to happen to the great rivers of Asia, we have, I think, sort of medium-term risks from precisely what you were saying, which is that countries look after their own. And the thing that concerns me most is the sense that there's in many ways a zero-sum game in this part of the world, seen in terms of its shared importance and the fact that it could be a uniting factor. It could be a uniting factor that 1 billion people depend on the health and vitality of these ecosystems. And I think certainly what many environmentalists and activists are trying to make clear, that actually there's a shared interest in looking after this and trying to do something to arrest the pace of climate change. It seems to me that in some sense the opposite thing is happening, which is that the greater on the horizon, more there's a sort of closing of ranks in a sense of looking after one's own. And I think you see this even in the simplest ways, how difficult it is to get water flow data from the Himalayan rivers. The NGO, The Third Pole, I think, wonderful job of trying to pool some of that information. But in some ways, India and China have had plenty of conflict even about disclosing water flow data in that part of the world. And so I think there are many risks which lead up to the risks that you talk, which the IPCC points out. But in a sense, there are, I think, sort of stumbling blocks even on the path to that.
Yes, and I think in the short to medium term, with the melting of the glaciers, there'll be too much water, and so there'll be flooding, cause of loss of life, and so on. And then over the longer term, we lose that supply of water that more than 1.5 billion people depend upon for all of their water needs. There's an interesting story here. You should tell this one now, your next book, about this and how it will affect the future of Asia, because I think it will sea level rise, and that's going to flood some of the deltas, the loss of rice crops, and so on. But I think the biggest threat is what's going to happen to the Tibetan Plateau, which is often referred to, as you know, as the third pole, because the amount of ice, it follows behind the Arctic, which is behind the Antarctic, but this is the third largest, and its fate is the rapidity of loss is uncertain, but there's enough CO2 in the atmosphere already that the probability of losing the bulk of those glaciers is very high. Sunil, this has been a great lecture. When we get over this pandemic, I'd love to have you come out and give a talk, and we could pursue some of these topics in greater detail. And
thank you so much for having me.
It was interesting with the International Indian Ocean Expedition. That went on for 2.5, maybe almost 3 years, I guess, and generated an awful lot of data. But today, we get more data in one day than was collected in that entire 3 years. And one of the big challenges is to transform the data into information that can help develop policies and maybe make people make some better decisions. Sunil, thank you very much for your talk. We really appreciate it. And
Thank you so much. It's been a pleasure. Thank you.
we want to wish you and everyone watching good night. Stay well.